Alright, so let's go ahead and take a look at this quiz problem number 2. So, first of all, we know it's a mean. We know that we're saying that the males are greater than the females, so mu1 is greater than mu2. That's our claim. So H naught is always, always, always equals, right? So mu1 equals mu2. Since that's not our claim, then H1 has to become our claim, that mu1 is greater than mu2. There should be a 1 there. Sorry, my bad. And so we're going to use the word support. Critical value, let's see. This is a right-tailed, greater than, so it's right-tailed. And it's mean Mr. T, mean, so I'm going to use the T distribution. My degrees of freedom is 50 minus 1, and my alpha is 0.1. So this is going to be one-tailed, alpha is 0.1. Let's go ahead and look that up. So alpha is one-tailed, 0.1, using this first column. And my degrees of freedom is 50 minus 1, so 49. Alright, so here, I don't have a 49. I have a 40 and a 60. So remember, I always have to round down. So it's going to be 13.03. So that's going to be my degrees of freedom, 13.03. And it's going to be positive because it's right-tailed. So critical value is 1.303. Right-tailed, I'm going to shade to the right, and then my test stat. So x bar 1 minus x bar 2 over square root of s1 squared over n1 plus s2 squared over n2. So 8.6 minus 7.9, right, because my x bar 1 is 8.6, my x bar 2 is 7.9, and then my s1 is 3.3 squared over 50, and then my s2 is 3.5 squared over 50. So then if you put those into the calculator here, we'll go ahead and do it together. Then we'll start from the inside out, right? So 3.3 squared plus, divided by 50. And the nice thing about this is, since it always takes the square first, and then the division, then it goes in order of operations, and I can just even do the plus because that'll do that last, which it should. So plus 3.5 squared divided by 50. So the nice thing is the order of operations works out perfectly here. So I get, inside of the square root, I get 0.4628. I need to square root that. So a lot of you guys like to square root it like this and see the square root symbol right here with the square root right there. So you can do second square root and get the square root, and then you can put in second answer, which is this one right here. If you look down here, the ANS, you can do it that way also. And that will also give you, instead of doing it my way, which is raising it to the 0.5 power. Either way, you're going to get 0.680. So we'll have 0.7 divided by 0.680, 0.68, and you get 1.029. So here is our test stat, 1.029. Totally, it's almost in the guilty area, but it's not. It's absolutely in the not guilty area. So we do not reject H naught, which means we do not have enough evidence. Remember, these go together. Whenever this is not also. So this step 4 impacts this step 5 by if this is not, then that's not. If this is do, then this one is. Right? It just kind of goes like that. They match up. So I do have enough evidence because I do not have enough evidence because I did not reject H naught. So there's not enough evidence to support. Remember, support comes for your H1. My claim was H1, so I'm going to use the word support there. Claim that colleges have more men's sports than women's. Okay? And again, this is on that PDF, which will be posted online on Canvas under Board with PDF, if you have any other questions. Okay. So you guys go ahead and do lab problem number 4. Let's take a look at it very briefly. Jacob, can you go ahead and read this for us? Jacob? Samantha, can you read it for us?
Lab problem 4, a researcher wishes to see if the average weights of the newborn male infants are different from the average weights of newborn female infants. She selects a random sample of 10 male infants and finds the mean weight is 123 ounces and the standard deviation of the sample is 8 ounces. She selects a random sample of 8 female infants and finds that the mean weight is 116 ounces and the standard deviation of the sample is 5 ounces. Can it be concluded at
Alpha
0.05 that the mean weight of the males is different from the mean weight of the females? Assume that the variables are normally distributed. Draw a picture and show all 5 steps.
Great. Can it be concluded, we want to conclude that the weight of the males is different from the weight of the females. So the males is different. Different means not equal to. That's my claim. Right? I'm concluding something. That's my claim. So my claim is that they're different. That means that that's going to be my different, not equal to is going to be my claim. Is this a mean or is it a proportion? Mean or proportion?
Mean.
Yep. You guys see the word average there? If you have the word average or mean, then that's a mean. So this is going to be a mean, so it's going to be mean Mr. T. Mean Mr. T. And what else we got? Let's see. We've got okay, so we got samples. So here's a sample of 10. So my first sample is going to have 10 people, 10 males, and their mean weight is 123, and the standard deviation of that sample is 8. And then we're going to take another sample. Another random sample, this one of girls, and we're going to have 8 of them, and you find that their mean weight is 116, and their standard deviation is 5. So that's all your stuff. So this is the first one, the males, 10 of them, mean of 123, standard deviation of 8. Here's the second one, 8 of them, mean of 116, sample of, standard deviation of 5. So that should give you guys everything you need. I'll give you guys, say 10 minutes to work together, and I'll pull you guys back in.